Well, good morning. Good morning. I am Jeffrey Palermo. I'm the Chief Architect of ClearMeasure, and we are a DevOps-centered software engineering firm serving the greater United States. Over my 2 decades plus of working with custom software, I've seen scores of modernization projects, and I know the challenges that an aging system proposes. Today, in this webinar, I'm going to show you a faster path to software modernization, regardless of which of the three major strategies you choose. And I know how busy you are, all of you on this webinar. My goal is to get you out of here in 30 minutes and not be a long, droning, hour-long webinar. So why don't we go ahead and get started? Logistically, you can chat amongst yourselves, and if you wouldn't mind, would someone please confirm that my audio is coming through loud and clear, just in the chat window? Put something in there, and then logistically, you can ask a question via the Q&A window here in the Zoom software. Awesome. Thank you. Thank you all for that. You can ask a question in the Q&A window, and I'll make sure that all questions are answered either during the webinar or at the end. I won't close the webinar until all questions are answered. I'll promise you that. And we're going to talk about the challenge of aging software today and why we find ourselves in need of modernization. And then we'll explore some symptoms of an aging system, and we'll look at the overall roadmap of how to plan your modernization, including available strategies, the detail of each strategy, and then how you go about executing. At the end, we'll share some of the ways that we can be of assistance to you in your modernization initiative. And the context here is I think you're here because you have a custom software system that you're trying to modernize. You're trying to carry forward. You're trying to figure out what it's going to look like and carry it forward over the next 10 years. And there's at least some element of the system that doesn't want to move forward. So the challenge, you might call it a legacy system or not, but a system that's showing its age is not resilient to change any longer. And when it goes down or has stability issues, business disruptions occur. And these systems are important. These systems are no longer able to change at the pace or in the way that is necessary for your organization to execute its go-forward strategy. And when the software system starts holding your business back, you have to address it. And probably some of your own staff are asking for some serious changes as well, just working with it. So let's dive into the problem a bit. We have an aging system, a legacy system. I mean, it could be a really old platform. Certainly COBOL mainframe systems are called legacy system, but there are many of our clients actively doing fresh development in older systems and doing well with it. And I mentioned that to illustrate that an older platform or language version alone doesn't cause a system to be the cause for business delays. But an old platform may be a symptom you're seeing. If you're using classic ASP or any of those, it may be mentioned in calls to replace the system. And your staff or your managers may be reporting problems retaining your developers or even recruiting new ones once they hear that they're going to be working on an older platform. The candidates, they may be opting for other companies when they learn about that, and they want to work on the newer, the latest, the greatest. And finally, you might be experiencing instability. That's another common problem. And if changing something breaks something in a seemingly unrelated part of the system, your staff is going to become hesitant to make changes because there's going to be fear there. And so these are symptoms that we all see, but there could be root causes lying under the surface. And some of the common root causes that we see in the bottom right, and we'll talk about those a little bit more: lack of maintenance, the perceived lack of opportunity, again, with retaining and recruiting, and then an insufficient development environment that's contributing to the system's resistance to change. So let's cut right to the chase. The three strategies, these are you have three strategies essentially. Every course of action is going to fall within one of these three strategies. So the three strategies for modernizing an application are package replacement, rewrite, or fix and upgrade. And regardless of the shades of gray or some of the details, these are the three choices. We'll ignore what is a fourth strategy, but that strategy is to do nothing and just wait. And it's basically the absence of a strategy, but it's the default. Just kind of kick the can down the road. So each of these strategies has some benefits and it has some drawbacks. And the package strategy promises to be the quickest to a full replacement, but it's still not quick or cheap. We are talking about 7-figure budgets for any of these, for any significant software system that's mission critical to your business and been around for a significant period of time. So the people who are selling these packages, the sellers tout faster timelines than a full custom rewrite. And I think that's true. You could rewrite in a modern technology like C# and Azure, or you could fix the problems that you're having with the system. So those are the three options, and this is how they lay out from a timeline and the relative time to seeing value. Okay, when you could actually have people using it and whatnot. Now, this third strategy at the bottom, the fix and upgrade, it seems far-fetched. I mean, your own people are telling you the problems with the system, and the reason you're in the situation that you are because you haven't been able to figure out how to just fix it and upgrade it. You'd love to do that, but it's been too hard. So you're looking at the first two strategies. Your people have tried to fix and upgrade things for years, and you still find yourself with a system resistant to change. So strategies 1 and 2 look promising, but the duration that you have to wait until real usage is a problem. If you can't change your system, then you have to replace it. And then you have a risky cutover event down the road when you're preparing the new system, and then it's finally ready, and then you have a cutover, but people have been using the existing system in the meantime. And so 18 months to several years is typically what people talk about and people think about with significant software systems. And that's just hoping that it can be done in 18 months or a few years. That's problematic because your business can't do nothing for 18 months. These are big, significant systems. All right, so let's figure out how to see some value quicker. And if we can segment the system and do some interim releases, then we can capture value quicker. And that's a better way to execute the same strategy. But if we're going to have a release where some of the new and some of the old are in place, then we have to be able to change and refactor our existing system. Okay. So again, any of these strategies are viable, and there are people who are replacing custom systems that were built in the past with some of the newer, more capable ERP or CRM packages or manufacturing and inventory packages, all kinds of awesome packages that have come out in recent years. And there's people executing strategy number 1. There are also people executing strategy number 2, and there are people executing strategy number 3. So all 3 strategies are viable. You just have to evaluate your situation and figure out which one you're going to take. So we want to, the previous slide showed some of the risks and have an extended time frame until we actually see some value from strategy number 1 or 2, so that if we realize that regardless of the modernization strategy, we're going to have to change something in a significant way, then we must regain control over the system that we have. Otherwise, we're going to essentially be on the previous slide, and we're going to commission a long an expensive project, and then after that, set up a highly risky big bang cutover event. And we know that those types of projects love to fail, the ones that go for a long time, and then we have this big cutover event way down the road. So I'm not here to sell you on a particular strategy. All these are viable, but I'm here to tell you that even though you have an aging legacy system that's hard to change, you must do what's necessary to regain control over it. If you don't, you're sunk, because you're going to have that extended period of time before you can actually start using it, and you're going to have that big cutover event. Okay. So let's talk about how to regain control. It's more than just having a way to execute changes. This change cycle that you're seeing on the screen, it probably looks familiar to you, and it revolves around a way to build and deploy the software, but it's woefully complete. Yes, plan, code, integrate, package, release, operate, learn. That's general stages, and even with the DevOps movement, where these are twisted into a sideways figure eight. I like to untwist them, by the way, but these are the stages, and at the center is an automated DevOps pipeline, which if a legacy system doesn't have that, then, and most likely it doesn't, then it's really hard to change things with any type of cycle. So to execute our modernization, we need to regain control over it in order to make some changes so that we don't have it completely off to the side, building up something new with no integration. So we have a model for that, and it's called DevOps-Centered Software Engineering. I was here on the screen. Regardless if your system is COBOL, old platform, or just older .NET, or even if you have a poorly designed system that you inherited, you need to be able to change it. And the center of this model, the center is the foundational infrastructure necessary to make changes and redeploy them, the systems. But there are other layers of capability that are needed as well. And you'll use these to regain control of that system and during the entire modernization as you make some fairly significant architectural transitions. So of all of these layers, each of them must have a sound strategy, be executed with discipline, and have objective measures in order to really control the system that you have in order to make any change. So let's just dive into what a pipeline looks like. Before we move on, I want to show you the basic structure of an automated DevOps pipeline, and you absolutely must have one for every application that you're managing, aging, or even if it's brand new. And not having one almost guarantees that it'll show its age as soon as the original developers leave your company, or in a lot of cases even before, as productivity slows and they get bogged down. And this design, by the way, is part of a larger design poster. And if you post in the Q&A window that you'd like this poster, then we'd be happy to send it. Just ask for it or follow up afterwards. We'd be happy to send this DevOps poster to you as a full-size PDF. It's formatted for architecture D paper so that you can print it on a plotter and hang it up if you like. And I know this is a highly shrunken technical blueprint for the structure and flow of a pipeline. It's implemented with I know this says Visual Studio Team Services, but Azure DevOps Services and Octopus Deploy with continuous integration and a 3-tier deployment pipeline, which, by the way, you'll never have fewer than 3 environments, even for simple applications or microservices, because you got to have your full system test or acceptance test environment. Then you have a manual test environment like UAT, and then you have production. That's the minimum. So we've done some other webinars that deep dive into all the details of this model, but please reach out if you need more information on how to set up a software system for continuous integration and automated deployments, not just the front end application, but also the database. That's just as important. Again, no matter if your system is really old or just an aging design on a fairly modern platform, your environment starts with this. And you will continue to have a very hard time making any changes without this basic infrastructure. Now, this webinar isn't about this, but I just wanted to show you, and if you've seen some of the previous webinars, that we've done a few weeks ago, a joint webinar with Octopus Deploy. We also did one with Redgate focusing on database DevOps. You've seen more of this in detail, but you can follow up if this is new to you. We'd be happy to help you out. Okay, so there's many practices available. Let's go through these layers. Let's go through these layers of DevOps-Centered Software Engineering that will help you gain control of your existing legacy systems so that you are free to execute any one of the three strategies that may be appropriate to you. So there's many practices. Best practices is one of those funny words because what is best? The best is different for every situation. But the truth is there's tons of practices out there. You have to choose which ones are appropriate for your team, for your system, and do some analysis and declare, you know what? We have found that these practices are going to be the best ones to use for this system and this team, and then do it and then execute. So there are many practices available, but there are some of particular consistent usefulness in a modernization. Feature branching, very, very useful. That's making small changes and redeploying frequently, and clustering up groups of commits with feature branching. And by the way, as a quick aside, trunk-based development is gaining a lot of traction over other branching strategies like Git flow, for example. And trunk-based development, it's interesting that it's called that because all of the branching strategies use branching, but how they use branching is different. So trunk-based development, I think there's a website, trunkbaseddevelopment.com, basically says your feature branches need to be insanely short in lifetime duration. And if you have a feature branch that lives more than a couple days, that's a problem. And you should target creating a feature branch on one day and integrating it back into master within a 24-hour period of time. So it's basically staying very close to the trunk, but you're still using feature branches. So don't make individual commits directly on your master branch. Make them on a branch that you can go through an inspection process wrapped with a pull request, and then and that keeps you safer. Another practice is refactoring, improving the structure of existing code without changing its behavior. You're going to have to do some refactoring, insert some seams. If you're looking for a book to help working effectively with legacy code by Michael Feathers is a very good, I mean, it's over 10 years old now, but it's a very good book. And it covers how to insert seams and ways to break apart existing systems where maybe that wasn't the original design. And then another practice you have to have is continuous integration. That's bringing together the changes of various people so that no single change is large. All right, so the next layer is defect removal. You're going to do big changes during this modernization, and you need to be able to find defects. We want to prevent defects when you're making new changes, but find the defects. So start with full system testing, which is the inverse of test-driven development. When you're doing a new system, you do the three types of testing, first with unit testing in the small, then with component level integration testing to make sure that the different components of the system work together, such as the core of an application and then the SQL Server database. That's a type of component level integration testing when you're making sure that going through the connection string and the type of command connection and the object relational mapper is generating the right type of queries and the table structure is compatible with those queries. That's the second level of automated testing. And then the third level is full system acceptance tests. And if you're using Scrum, for instance, that calls for acceptance criteria, then implementing the acceptance criteria as full system acceptance tests that then run automatically is the best implementation of that practice. But when you have a legacy system, you go the other way around because you don't have any covering tests or very few. So you don't start with unit tests because the code was not designed to be able to be tested by isolating different parts of the code. So instead, you start with those full system tests that cover large parts of the application so that when you accidentally break something, you instantly get alerted that you broke something, but it doesn't exactly pinpoint where you broke it like a unit test does. But either way, start with full system testing, and then get your full system covered with that. You'll probably want to use formal recorded regression tests with Azure test plans. That's a way for you to document how you test this thing, and then have various other stakeholders record that they are actually executing these tests, and get formal about that, because the system is large, and if the original people who developed it or were experts in it have left the company, then just learning all of the nuances of the system can be a challenge. And then the definition of done. With each refactoring, I talked about covering tests have to be run, and make that part of the definition of done of every change, and add in other checks to keep you safe. And that will help remove defects. Also, adding static code analysis to your build will find issues that probably been there for a long time that you didn't know about, but might be surfacing in various other ways. Okay. So next layer is team workflow. You need to get back in control of your system. And so on your Kanban board, where you have all your swim lanes, go ahead and add extra columns to your Kanban board. Some extra columns for legacy scenarios might be a column for understanding user scenarios, and another column for add covering tests. If you're about to make a change in a certain area, then you're going to need to do that, and you don't want to just have a big in progress column where, oh yeah, it's been in progress for how many days now. Break up these bits of work so you can track them and you can see what's being done. And if you've had staff turnover, your people likely won't be those expert power users, like we mentioned, and how the system is used in various scenarios. So when changing something, special time needs to be allocated for filling in these knowledge gaps and for talking with users. Record those users demonstrating how they use the system for common tasks they perform, and spend some time, like I said, adding covering tests for all discovered transactions for the scenarios that you walk through with the users. Okay. And next layer is architectural blueprints. So Philippe Crucian in 1995 published a model, and you can search for it. There's a PDF describing it. It's called the 4+1 view model of software architecture. The 4+1 view model of software architecture. And it's also referred to as software architectural blueprints. So it's a model for iterative emergent architecture. If you have a big legacy system like this, you need to know the shape of it. And we have clients who, when we started helping them, there was no drawing of what the system looked like. There might have been a drawing for what the server footprint was in the data center, but there wasn't the layers that you typically need. So the 4 layers are physical, logical, process, and development. The physical is the runtime layer. That is the server topology in the data center. And you can see, oh, we have this many servers. But then the logical is, regardless of the scaled out footprint across servers, what are the different areas or components of the system, and what does the dependency map look like between them? And then the process layer is for common transactions. What is the flow of data through the logical components of the system? And then the development layer is what you would teach a developer when they're joining your team. What does the development environment need to be structured like, from a local workstation to the number of libraries and packages and tools that you have to have, along with the DevOps pipeline infrastructure for builds and deployments and things like that. So you want to update the 4+1 architecture and keep that current and make that your friend. That aligns where you're going, because if you're replacing it with a package, for example, that first strategy, but you need to let that package integrate with a particular part of the system that is embedded and wasn't designed to have an API. You may have to insert an API. Well, then you are going to be changing you're going to be changing at least the logical layer of that architecture. And so you need to create a to-be version of the architecture and kind of talk through what it's going to look like and get everybody on the same page. So cast a vision for what that system would look like when it's finished with that major refactoring, and draft transitional architectural states at each milestone. Use this to align your team and to inspect what is changing. One of the replacement patterns, if you're going for a wholesale rewrite, is the strangler pattern, whereby, and you can Google that, the strangler pattern, where you refactor parts of the system to disconnect them or take them offline one at a time. Then you just leave the code there because it's dormant for now. And it can be less turbulent sometimes than removing the code if it causes the structure to start to crumble, for instance. Okay. All right. So operations, and it seems like more and more modern operations and new operations are going to the cloud, and they're changing from just servers in a data center in some way, even if they're hybrid. But if you have that system and you're preparing for one of these three strategies, then there's a few things that you want to do when it comes to operations. You want to assess the state of your logs and observe your observability characteristics. Your legacy system is probably not as testable as you would like, but it might not be as observable as we need either. And if you can't trace what users are doing through the system in detail, add more telemetry and provision a centralized log and analysis environment. There's plenty of products that will bolt into existing systems for that. Also, make the team recreate a new scaled down production environment or any environment. You need to, I know I just scared some people. You need to prove to yourself that you can create a production environment. If you can't, then you're one step away from an outage turning into a disaster. Maybe some of you know that, but just going through the learning of creating a new environment is going to be liberating in some regard, and it'll force the learning required to automate environment recreating, which will enable you to get a robust DevOps pipeline around this existing system so that you can make the interim changes necessary for executing any one of the three modernization strategies. Again, our goal is to regain enough control over our system so that we can make the needed changes as we move along our chosen modernization strategy. So the perceived easy way out of a system that's hard to change is to just avoid it or go down a replacement route, which means you wouldn't have to touch it, quote, you wouldn't have to touch it, and build something up next to it and then cut over. But facing the storm gets you through it quicker. Let me share an example. Buffalo and cows are different, and in the plains where the buffalo roam, there's herds of cows and buffalo in the middle part of the country, and a lot of times there's storms that come from the west, and they typically come from the west, those storms in the plains, and the animals can see the storm coming. The cows will start walking east because they see the storm and they start walking away from the storm. But the herd of buffalo, they see the storm coming from the west and they head straight for it. Now, it's kind of counterintuitive. Well, what happens is the storm moves from west to east. And so the cows, they'll move east, but then, they'll run out of room and the storm eventually catches up with them. And then the cows, because they're moving east, the storm still goes over them, but the cows end up being in the storm a long time. The buffalo, they start moving west. Now, they start getting wet sooner. They get to the storm quicker, but because they're moving west and the storm's moving east, they get out of the storm quicker. So we can think about that when we're tackling our legacy system. Be the buffalo. All right, there's a few examples here. I won't go through them in detail of how we've delivered results for our clients for modernization and legacy systems and helping them get through. Be happy to share those with you. There's a few ways that we can help listed on the screen. But one of the easy ways is to get some help is to have us do some architect level advisement or consulting. And if you'd like a second pair of eyes on your organization, environment, or processes, we're happy to help there. And if you need us to take care of something major for you, we have a full capability to do that. And I personally oversee all my projects. But let me get to some of the questions here. There's one question: will there be a link for the YouTube video so I can share with my coworkers later? Yes, we will make a recording available to you. I think there's some other questions. Let's see. Asking for the poster. Yep. Okay, let's see. My question would be, would you approach a large application that was written by many different devs, but no common architecture policy? Do you document? Do you introduce unit tests? Do you tackle layers first, data, logic, front end? That's a good question. And it sounds like a big challenge, as all these are. Many different devs, but no common architecture policy. Okay, so it sounds like you can look through different parts of the system and you can almost pick out that the first group of developers use some patterns a certain way, and then a different set came on and they did. You can almost identify different layers of patterns in the system, and the code base is not even consistent with itself. We've seen that, yeah, quite a bit. That's very common because developers come and go, and there's no consistency even within the same code base. So that happens. I think all of the points that I just made apply. What you want to do is you want to have the ability to redeploy what you have very quickly. You want to be able to adjust the environment. You want to be able to make a change, recompile whatever tests you do have, whatever validations you do have, and at least be able to redeploy that system very quickly. So that means you need to be able to create a pre-production environment that you can rebuild very quickly, or at least redeploy very quickly. That includes the database schemas that the system depends on. And once you have that, then another one of the important tactics are adding covering tests. Even before you start going in and starting to change things, you want to give yourself some covering full system tests, so that if you make a change that breaks the system, that you at least know about it. And that way, what you are doing is you are speeding up the cycle time for your existing developers. And when they have a very quick cycle time, they become less afraid, because if they break something and they know that, oh, I broke something, and so now the build is broken for the rest of the day, for the rest of the team, then they're not going to be bold. But if they know that they can work on a feature branch and have a environment that's dedicated to that feature branch, for example, or rebuilt from scratch, even if you need to spin up more servers, maybe you can do it in Azure, spin them up on demand, or even multiplex some instances of the application on the same set of servers, whatever environment tricks that you can do, so that on a feature branch, you can have a build, you can have a deployment, and you're essentially enabling an individual developer to experiment very quickly and be bold and not have any consequences for accidentally breaking something. That's a huge enabler. So do we document? Yes, we document. The 4+1 architecture is the best documentation in this situation, so that we can get a shared understanding of what the shape of the system is, and we can annotate that 4+1 architecture from a user perspective. That I think product management and some other stakeholders would have more to comment on that. But first, from the ability to change the system, the 4+1 architecture document is highly enabling. So I'd encourage that documentation. All right, data logic and front end. I don't think that there is a rule of thumb on that. When you analyze it, you probably want to look at which one is going to have to change first in order to enable some of the seams or to segment the application in the way that you need. I don't think there's a rule of thumb on that. All right, let me go down the questions. Okay, I think 7 more were answered in line. Yeah, a lot of you are asking for that poster. No problem, we'll get that to you. Okay. All right, so next slide. And this is the last slide. Our model for DevOps-centered software engineering is useful regardless of the 3 modernization strategies that you choose. And we are happy to help you guide you through, even if it's just answering questions, regardless of the 3 strategies that you're on. You're going to need to have some control over your existing legacy system. And we're happy to help you with that. This is my direct contact information, by the way, on the screen, my phone number, email address, Twitter. So right after this webinar, if you call me, my phone's going to ring. So feel free, and let's chat. And one favor that I would like to ask of you all is, and do it in the, you don't have to do it in the chat, where everybody can see if you don't want to, but in the Q&A window, if you wouldn't mind, I know we've been doing our webinar series since December. We've done weekly webinars on a variety of topics, and we've just been blown away by the number of you guys that come to these webinars, which is fantastic. And this is meant for software leaders, for software executives, for people running and leading software teams, and the stakes are high. And so we're hoping to provide value. In the Q&A window, I would love to have some topics for future webinars to keep these going. So if you wouldn't mind, just anything that you are looking, any challenges that you're having, any topics that you would like to see in future webinars. We're a Microsoft, and we specialize in Microsoft and cloud platforms. And that's our specialty. We're a gold Microsoft DevOps and cloud partner. So that's kind of our specialty here. And yeah, I see the topics coming in. I appreciate those. So feel free to contact me and add in your topic requests in the Q&A window or the chat window, and I'll leave that open for a while. And you can also reply to the email that you've received. But I appreciate the time that you set aside. We've gone, 38 minutes now. I like to get you in and out, get the content delivered. And I'll leave my contact information up on the screen. We'll go ahead and close the webinar. And until next week, we have our webinar schedule on the website. And of course, we'll send out an email in the next day or two announcing next week's webinar. So appreciate the time, and I hope everyone has a great day.